All right, simplifying expressions. So we started with fractions because I wanted to jog your memory about reducing. Reducing is literally doing like 4 divided by 4 is a 1. So when you reduce a fraction that looks something like this, 4 over 8, your brain immediately goes to, oh, well, that is 1/2, clearly. But what you've actually done is you've broken it up. This is 1 times 4, and this is 2 times 4. And you've actually just canceled out those 4s because they're just a 1. That's what you did when you reduced fractions. And so that's what we're really going to do with rational expressions here. We are going to look at what they have in common. And if the top and the bottom has something in common, you can cancel them out because anything divided by itself is just a 1. There is a little bit of a caveat here. The denominator cannot be 0, but that's something that we should probably always know. You can't divide by 0. And so they give us some examples of rational expressions. A variable over a number, a variable over a binomial, or a polynomial or over a polynomial. Those are all examples of rational expressions, all right? And so how do we simplify them? The first thing we talk about when we're talking about simplifying them is we have to realize what things cannot happen. With rational expressions, the only thing you typically have to worry about is that denominator. So if I said what is excluded, I'm saying what would make my denominator 0. And you're going to say x cannot equal these numbers because these numbers would make my denominator 0. And so if I look at something like x squared minus 1, I actually don't care what happens in the numerator right now. The numerator can be 0 all day long. The denominator cannot be. And so I can say, well, what happens then? Whatever happens, that cannot be 0. So then what makes that 0? Well, 1 would make it 0. What else would make it 0? There we go. All right. So my excluded values then are 1 and -1. Those are excluded values. So that's really the only thing you have to worry about when you're doing rational expressions. You have to just make sure I'm not dividing by 0. Simplifying them. All right. So it has two things here. It says, I want you to simplify this, and I want you to state any excluded values. Any excluded values. So there's a couple things that cannot happen here. We're going to look at the denominator first. We're going to look at excluded values first. So we're going to say 5xy plus 40y. What would make that 0? So we have to go back to how do I solve something like this when it's equal to 0? I solve by a little method called factoring, all right? So I'm going to look at both of these. What is the 5xy and the 40y? What do they both have in common? Numbers and variables. 5 and y. So if I divide this one by 5y, I have x. If I divide this one by 5y, I have what? 8. So then to figure out what would make this thing 0, 5y, if that is 0, that will be 0. And if x plus 8 is 0, that will be 0. So if y is 0, I have a problem. If x is -8, I have a problem. That's how I figure out my excluded values. So these would be my excluded values. When y is 0 and x is -8, we have a problem. So the way you tell me that is you say y cannot be 0, x cannot be -8. That's how you answer that piece of the question. All right? The other part of this question, it says simplify. The way you simplify rational expressions is you factor them. That's the very first step in doing this. We've already factored the denominator. The denominator looks like this. We're going to do the same thing to the numerator. What do 5x squared and 40x have in common?
5 and x.
5 and x, right? Oh, that's 5y. I wrote that because I'm jumping ahead. So we have a 5x on the outside, and on the inside we have x plus 8. When I simplify, I am looking for what does the numerator and the denominator have in common that I can cancel out, just like I did when I had 4 over 8. And I said that's 1 times 4 and 2 times 4, and I canceled my 4s. All right, so what do they have in common?
X plus 8.
Right, so this entire group I can cancel out. Anything divided by itself is just 1. Anything else? What else can I reduce? Yeah. 5 and the 5 can reduce. So this whole thing simplifies to just x over y. And then I'm going to say, and y, by the way, cannot equal 0, and x cannot equal -8. Find your excluded values first. They follow after you simplify. Even if it's no longer an excluded value once you simplify. Looking at this, you wouldn't think that -8 would be a problem. But it was originally, so it still is. So when you're doing something like this, you want to look for your greatest common factor. That's a term we've used since middle school. Greatest common factor, take it out. And then you have something left. Greatest common factor, take it out. Unless it's exactly the same, you can't cancel. And you're going to reduce your numbers like you would any fraction. You're going to reduce your variables like you would any variables that we've done for properties of exponents. And then whatever's left, you leave. If it says leave in factored form, no, to answer the question, you do not have to distribute. Leave in factored form, and that's how you're usually going to leave it for me, in factored form, unless I tell you otherwise. You're going to treat just like a fraction. You're going to factor these, reduce just like you would a fraction. 2 m's and 3 m's, these will both cancel, and you'll have only one left here. One n will cancel, and that's why you have the 3 left. On the bottom, you need to factor, and a will come out of both of these, so you have a squared plus bc. Down here, a 2 and a b will come out of both of those, and you have your a squared plus bc. And then you could have canceled these. And that's where you get just the a on top and the 2b on bottom. So opposite factors do not mean like conjugates. They don't mean like we had before. We had a +2 and a -2. Those are not considered opposites, all right? Opposites is when they're actually flipped. So like if you have an x minus 2 and a 2 minus x, those are opposites, all right? With something like that, and they give the example here, 3 minus x, x minus 3, you can actually factor a -1 out of one of them. When you factor a -1, everything changes signs. The +3 becomes negative, the negative x becomes positive. So negative x plus 3 and x minus 3 are the same thing. You can rewrite it and see that. And then you can cancel opposite factors and you're left with just a -1. So something like this, there's nothing you can do to simplify it to get rid of it. But something like this, you can take a negative out of one of them and then they're the same factor and you're left with just a -1. So if you look at this one example that they gave us here, I look at the top and I can say, well, the first thing I can do is I can take out an x squared. So I have 6x squared minus 5x plus 1. On the bottom, I can take an x out and I have x minus 2. You want to keep factoring. So this is factorable, all right? This factors into 3x minus 1 and 2x minus 1. And that is an x right there. And then on the bottom, I have an x and a 1 minus 2x. I could write it correctly, that would work. So I have this. So you can clearly see my x's will cancel, all right? But here I have opposite factors, 2x minus 1 and 1 minus 2x. The only way I can cancel those is to leave a -1 there, all right? If they're opposite factors, one minus and that one minus the other, then you can cancel them and leave a negative. So when I simplify all of this, I actually have no denominator, which is fine. And I have a -1 and the 3x minus 1 on top. So negative 3x minus 1. You can either distribute it or you can leave it like that. Either one's fine.